first part I'm going over here is unit testing. We'll talk about the features, we'll talk about how you create unit tests, we'll talk about asynchronous unit tests, which is something new in GWT. We'll talk about how you run unit tests, and hosted mode and web mode, which are two different kinds of ways you can run unit tests. So first, features. We wanted to provide people with automated testing. If anybody's ever done testing by hand, you write like your class and you execute it and you kind of look at the output, and that really sucks. Having to do that manually, it's generally not good. And that's why pretty much every testing framework that exists out there today is automated. You get pass-fail, things kind of like that. We wanted to use a familiar testing framework that everybody more or less uses, and that's JUnit. There are some others out there, but JUnit by and large has most of the market. We wanted to integrate with the existing tools out there, and by picking JUnit, what that allows us to do is integrate pretty trivially with all the IDEs out there like Eclipse, IntelliJ, NetBeans, so on and so forth. Ant, there are built-in tasks for that, and even continuous integration like cruise control. Things we don't support with unit testing are UI testing. Specifically, things like, are the pixels in the right place? Does this appear right or look right? Instead, what we suggest is that people use Selenium, and that's an open source free tool specifically built for UI testing for web applications. And actually, we're working on a better integration with Selenium, particularly with this ensure debug ID function, which will basically help Selenium in terms of determining which widgets are where in the layout. So I guess the first place to begin really is how do you create a unit test? It's actually pretty simple. We have what's called a GWT test case. GWT test case is a subclass of JUnit's test case. More or less looks like a normal test case. So instead of extending JUnit's test case, you extend GWT test case, and the second step is to implement what's called get module name. If you've written any GWT applications, you know about modules, you use the GWT compiler, you specify a module, that's all that's going on here. You just specify the module name in your unit test. Let's see. So there's a lot of boilerplate involved in creating unit tests, and so we have a tool that you can use. It's a command line tool called JUnit Creator. It'll create a sample test case for you, can create startup scripts for you so that you can launch the test case easily, and an Eclipse launch config for those who are Eclipse users. Something new that GWT introduces to the equation is asynchronous unit tests. These are different from typical JUnit tests in that we allow you to test things that are asynchronous. Examples of this are things like RPC, UI events, anything along those lines. So normally if you were to test asynchronous things in Java, you could spin off a thread and do blocking like you would use wait and notify or things like that, and you could coordinate all of that. But you don't have those facilities in JavaScript. You can't create threads. So that's what this is all about. We add two specific methods to support that. The first is called delay test finish. And it takes the amount of time in terms of milliseconds to prolong the duration of the test. And the second is finish test, which is used to actually complete the test regardless of the outstanding duration. So, running unit tests. There are two execution modes I talked about earlier. The first is hosted mode, and the second is web mode. Hosted mode is when you're running effectively the Java code, right? You're running in a hosted browser, you're using the real JRE classes, you're running Java bytecode, and so that's what you're debugging with. Web mode is when you've got a real compiled JavaScript application and running real JavaScript. There are actually two sub-modes of web mode. The first, which is local, and the second, which is remote. Local web mode is when you're running in our own special hosted browser. Remote is where you can run your web application in an arbitrary supported browser. So to go through this again, hosted mode is the default mode. You run your code as Java code with real JRE classes. They execute inside of the hosted browser. And the biggest reason to run tests in hosted mode is that it's just easy to fix bugs. If you're looking for problems and you need to determine what those are, you use hosted mode. Hosted mode is, so you'll use your IDE, like IntelliJ or whatever. We'll actually go through an example in a little bit. And I guess a little bit is now. All right, so what we have here is the async unit test. So what this test does right here, this is our JUnit style test method, test button focus. It's setting the focus on a button and then determining if that focus was really set. And for extremely arcane reasons, focus doesn't happen immediately. The only way you can determine if a widget has received focus is on receipt of an asynchronous event. So what we're doing here is we're getting the root panel and creating a new button, adding a focus listener on the button, adding the button to the panel, setting the focus, and then here is a use of one of those magic methods I mentioned earlier, delay test finish. So at this point, we're saying, even though we're about to leave the test method, I don't want you to actually finish the test yet. Wait 1 second, wait 1,000 milliseconds before the test actually finishes. And then in the final line of code here, we add a deferred command. So we're on-queuing a command which says, when I execute, if I really did receive focus, I'm done. This worked right. If I didn't receive focus, then it's, the test failed, exception. So we throw an exception to make that happen. And then, of course, like all unit tests, we have to specify the module name. So let's go ahead and give it a go, see what happens. So this is running, to restate before, this is actually running in hosted mode. We're using our IDE, we're using Java code, and it's busy compiling. Oh, looks like we got an exception, but I can't see it. Let's open that up a little bit more. It's off screen. Maybe if we do this, that's a little bit better. Wow, this shows really bad at 24-point font. Thank you. Well, I don't even think I can see that at the moment. Oh, okay. All right, great. Thank you. Darn PowerPoint. Okay. There we go. So we can see that a little bit better. So what we have here is we have a runtime exception. It said the button didn't get focus. Well, so I guess the easiest thing is just to debug through that and see why that would be the case. So we just hit our little debug button. IntelliJ is going to kick back up again, start the unit test, and then hopefully in a moment we'll actually land on a breakpoint. All right, so we're on a breakpoint and we're debugging our Java code. So we add the button. We add the button to the. There we go. So we get the root panel. We create a new button. We add a focus listener. Add the button to the panel. Set the focus. Oh, wait. That's what the bug was. So setting the focus, I set it to false instead of true. So maybe if I fix that now, rerun my test, we'll get better results. Oh, there we go. So we got a passing test. So we were able to go create a unit test, run it in our IDE, actually debug through the code, fix the problem, which is all great and awesome. And so that's the default unit testing mode. Now to go back to the presentation. So that was all of hosted mode. Now we can talk a little bit about web mode. So like I said, web mode is, oh, I'm sorry. Question?
Why do you have to end it with a deferred command, or why?
Oh, yeah. So the trick there is because it didn't look that way in the test, but what actually happens a lot of the times, like I said, is focus actually gets set asynchronously. And so what has to happen is, like, if we were to execute that in web mode and we do a deferred command like that, that way we can wait, the event loop pumps, like the JavaScript event loop pumps, and gives a chance for the button to gain focus, right? But because we were kind of debugging in hosted mode, that was a little different. Web mode. What we do in that case is that we actually compile that unit test, all that Java code, down to JavaScript. And then we execute that JavaScript in the hosted browser, or in the remote case in any supported browser. Web mode is a little harder to debug the problems because you just don't have an IDE that you can't debug. There are ways of attaching JavaScript debuggers. Like, I don't know if people are familiar with Firebug, for example, or Microsoft with Visual Studio. They have a JavaScript debugger, but it's arcane. You have to set special breakpoints, and it's really really painful. What is good about web mode is that there are certain problems. Like, for example, like we were talking about in that case, like focus is a little more asynchronous in web mode, and so it's easier to reproduce those problems in full-blown web apps than in hosted mode. And yeah, to make this work, you have to specify the -web flag because hosted mode is the default mode. So I talked a bit about remote web mode, but let's talk about some of the details there. Remote web mode is different than web mode and hosted mode because you actually get to pick the browser that you execute in. All the tests that you run will run in parallel. So what's kind of really great about this is that you can execute your unit tests on, say, Firefox, on Opera, on IE6, on IE7, on Safari 2, on Safari 3. Do all this in parallel, like just send it out to a farm, for example, and get all these results back. And it all runs in what appears to be a single test case. You just kick off that test case, boom, all the results collected all back. Pass or fail. And if it does fail, what happens is you get the results tell you specifically which browser failed. So the only trick, remote web mode is a little bit undocumented, so you might have to search a little bit for information on it. Tips and tricks generally about unit testing. Get module name. It's easy to get that wrong. You tend to copy unit tests, so you might have it in your IDE, copy it somewhere else, and then you can get errors that are a little awkward. The command line arguments, like I specified that, I told you that you had to specify -web to run in web mode. Well, it's not a normal command line argument. You have to use the system property gwt.args, which is weird, but that's just the way, unfortunately, JUnit makes us do that, right? JUnit is not really happy about taking command line arguments and passing them around. If you ever accidentally set web mode in your command line arguments and you have breakpoints set, it'll just fly right by them in your IDE because remember, you're not actually debugging Java code at that point. You're debugging JavaScript code, and you can't do that with your Java IDE. So you might be confused if you do that a few times until you realize, oh wait, I'm debugging in web mode. That doesn't work. There's a special option, not headless, which will show the what is called the GWT console or the tree logger. So if you use -not headless, normally that's hidden, but it will unhide it for unit testing. And GWT. Unfortunately, you can only use GWT in test methods. You can't use them in the setup methods, you can't use them in the teardown methods, you can't use them in static initializers. And you can't even use them indirectly. So for example, if you were in your setup method and you created a new widget or something which relies on a DOM method, which does like dom.createElement or something like that, that will cause the unit test to basically bomb. So it's an unfortunate limitation and probably something we can work around in the future. Okay, so that's more or less unit testing in a nutshell. Now we can talk about benchmarking, which is my favorite subject. So like unit testing, we'll talk about the features of benchmarking. We'll talk about how benchmarking compares to profiling. That's like one of the #1 questions I get about benchmarking. We'll talk about how benchmarking has been used to improve GWT. We'll talk about extensions to the unit testing API we had to make in order to get benchmarking to function. We'll talk about a real-world example, Hashmap Benchmark. And then we'll discuss micro-benchmarking in general. So, features of benchmarking. We do support micro-benchmarking. This is actually pretty tough because JavaScript's timer is super bad. We're talking resolution around 15 milliseconds on average on most platforms. And so doing a micro, is everybody aware of what a micro benchmark is? Okay, so let me back up just a moment. So a micro benchmark is where you're trying to time something that's a really small operation, like say the allocation of an object or something like that, right? So it's really small, and in order to do those normally, you need very high performance timers. So for example, in Java 1.5, they added system.nanotime, right, which is a really high resolution timer. So returns results in nanoseconds, usually accurate to to about that, to like hundreds of nanoseconds or something on a typical machine. But yeah, Java's timer is on the millisecond level. So milliseconds 10 to the -3, nanoseconds 10 to the -9. There's about a million level difference in order of magnitude difference there in accuracy. But we do lots of tricks and benchmarking to kind of tease out those kinds of problems. We support benchmarking both Java and JS&I methods. So if you've got a JS&I method that you want to time, we can do that with benchmarking. We avoid slow script warnings. So I don't know how many people are aware of this, but all the major browsers basically have little pop-ups that show up anytime you execute code just in a loop, and you don't give the browser the opportunity to breathe, right? I think Joel maybe talked about letting the browser breathe in one of his previous talks. So unfortunately, that's kind of like the whole goal of a benchmarking method is to just chew up a bunch of CPU for a period of time to get a good result. But again, we do some crazy hackery to prevent these slow script warnings from popping up while you're executing benchmarks. Accuracy, I talked about that some already, the inaccurate timer. And we allow you to benchmark on any browser. So you don't have to benchmark on just our hosted browser, right? We only have like 3 hosted browsers, right? Like one for IE, one for Mozilla, and one for Safari, right? But you can benchmark on any browser that GWT supports at all. Distributed benchmarking, just like I talked about unit testing, and actually this feature, Remote Web, was actually added specifically for benchmarking, but backported in for unit testing too. So not only can you unit test against a whole entire farm, you can benchmark against a whole entire farm, which is incredibly useful. So benchmarking versus profiling. We'll go down the benchmarking side first and talk about that. So one of the first feature, how do I explain this? one of the things about benchmarking is that it's comparative. It's used to compare results across different browsers, across different data structures you might use, even across different versions of GWT. So for example, we might compare like the results of some benchmark from GWT 1.3 to GWT 1.4. Algorithmic performance. This is interesting. So what happens is like we might say take an array list and say, well, how does it perform at 10 elements? How does it perform at 100 elements? How does it perform at 10,000 elements? And so benchmarking really helps you find the curve, right? Like for those of you who were in Scott Bloom's talk for the last session, he explained that there was some ON squared. He actually showed two graphs there. Those graphs were produced from benchmarking. Performance regressions. We really, really, really want to avoid things getting worse in another release. Always should be improving results. And benchmarking is neat because the results are actually useful to an audience in general. Profiling is different from this in that you're generally looking to identify your specific application's hotspots. You're like, my application's just not running fast enough. I have no clue why. You would profile. Profiling really relies on a high-resolution timer. You cannot do profiling without a high-resolution timer. And typically that means you're going to have to do some kind of low-level JavaScript VM integration. You're going to track allocations. So you're going to look at like things like how many objects were allocated and things like that for like GC pressure and such. And like I said before, as compared to benchmarking, the results are really just useful for yourself. They're not useful to give to a wide audience. While we do have benchmarking, we don't have any profiling publicly available now, but it's something that we are working on and we want people to have. So it's a work in progress, coming soon to a GWT near you. Improving GWT. So this is what we've done with benchmarking to improve GWT, and hopefully it'll give you guys some ideas about how you can improve maybe your own libraries, your own code bases that maybe you provide to other people or things like that. So one of the things that we found first was that there was terrible array performance in Safari. Once you reached an index, for example, of 10,000 in an array in Safari, every subsequent allocation would cause Safari to reallocate the whole entire array. So instead of getting sort of this amortized performance that was linear for arrays, you'd just see this exponential blow up, kaboom, and it was only on Safari. So we had to special case kind of that behavior. List box performance. We found that there were some DOM operations that were really bad. I think it was either on adding an item or removing an item, not sure off the top of my head, but we were able to replace that with a specific JavaScript API that made that just fly much faster. Array sort. We run into these problems all the time where we ask ourselves, what really would be the best way to implement this? And with arrays.sort, we decided, well, there are two major alternatives. We could use JavaScript sort, write JSON code, and basically ask JavaScript to sort the array for us, or we could hand write a sort. So we could write our sort in Java, have the GWT compiler translate it to JavaScript, and really it would seem like the native sort would be a better solution. And the reason why is because if your choice is, hey, let the browser run native C code, right, or have the browser interpret your JavaScript, but probably its own native code is going to be faster. Well, turns out IE6 really sucks at this. And so the native sort is bad. And so we have empirical evidence that we use to provide the best behavior for GWT, for array sort. String buffer, another example. We ran across behavior where we were expecting sort of, like I said, like with arrays, sort of like amortized linear performance in terms of allocation, but saw something that was much worse, so like n log n or maybe even worse than that with buffer allocations. So if you're writing your own benchmarks, we had to add some extra facilities to the API to help us out with that, to the testing API. So the first two things we add are lifecycle methods. These lifecycle methods help us separate out the extra setup and teardown. So unit tests normally have setup and teardown methods, but those aren't like per method. So instead, what we have is a specific begin and end tied to each test method. So if you have say a test foo function, you have an optional begin foo function that you can implement and an optional end foo function that you can implement. The begin will be called before, and the end will be called after. Arguments and test methods. So unit tests, JUnit tests only allow 0 argument test methods. You call the test method, where would the arguments come from, right? But it turns out that arguments are incredibly useful in benchmarking because what you really want to do is you usually want to execute something for many different permutations of something. And the example I gave before was with the data structure, for example. You would want to see, hey, how would this array list add if I had 10 elements in it, or 100 elements, or 1,000? And so basically, if you could have that come in as a parameter, right, and just have that change and execute that function over and over and over again for the different values of that size, that would be extremely useful. So we do. You're able to specify these parameters, and through GWT metadata, you're able to tell what values should be passed for those parameters. Okay, so we're back to another demo. This is the Hashmap Benchmark. So one of the things we ran into was regressive performance in Hashmap. So we put a benchmark together that helped us sort that out. So am I back to 800 by 600, or is this still 1024 by 768? Switch. Oops. I'll try not to go into too much detail here because it's a little sophisticated, being a real example. But let's look at one benchmark method just to begin with. So here's a benchmark method called test hashmap contains value int, and what we're doing here is just calling, as you can see, the contains value method on the map. That's really all this is about. We're effectively saying, how fast is contains value? We want to do it a bunch of times and just see how it does, and for a hash map that varies in size. So you can see the first thing that differs here from a normal test method is we have a parameter. We have integer size, right? And so basically we can have this test method be called for a whole bunch of different sizes. So let's talk a little bit more about that. There's this metadata. I don't know, are people familiar with GWT metadata at all? Anybody? What's a good example of where else metadata is used? Who's used GWT RPC? Anyone? So for you guys, exactly, GWT type args. GWT type args is a good example of metadata. It's the same thing. It's a Javadoc comment, and actually is really like a Java 1.5 annotation, right? And I don't know if you guys know this, but coming up in the next version of GWT, GWT 1.5, we actually support annotations. So a lot of the things that look like these Javadoc comments are going to move to real annotations. But in any case, so that's what's going on here. This is effectively an annotation. And this annotation is saying, for this parameter named size, I want its values to come from this field called contains range. So if we back up a little bit here and look further up in the file, we'll find this range, this int range here called contains range. And I won't go in too much detail about what int range is in of itself, but pretty intuitively looking at it, what you can see is that the start range is 10, the end range is 200, the end of the range is 200. We're adding to it at 20 at a time. And so the values that this range is going to take on is like 10, 30, 50, 70, 90, 100, so on and so forth. And so that's what's really going to happen with this method. This test hashmap contains value int. The benchmarking subsystem is going to run that for every value in that range automatically for you. No intervention. And that range is actually very flexible. That range specified in the metadata can be any iterator effectively. So if you can pass any, actually not iterator, iterable in the terms of like a Java 1.5 sense. So you can pass any set of values in there. In fact, it can be like a lazy set of values. So you could have a iterable that would generate like Fibonacci numbers if you so felt like it to infinity. What next? So for our test hashmap contains value int method, there's a lifecycle method there. It's called begin hashmap contains value int. And like I said before, these methods are optional. There's the begin method and the end method. And in this case, we implemented the begin method. And what we're doing here is we're taking the lifecycle methods take the same parameters as the test method themselves. So it takes the size, just like the test method, and when it executes, it populates the hash map. That's what's really going on there. The test hash map duplicate in adds method populates the hash map with that many entries. So we're saying effectively, before you go and run contains value, let's actually set up a hash map of the appropriate size and then run contains value on it. So what we're really seeing is, does contains value get worse as the size of the hash map grows, right? And that's more or less Hashmap Benchmark. One thing that would be interesting to do here is actually pull up a set of reports we could actually see what these guys look like. So that Hashmap benchmark right there actually generates this data. And so let's see, test hashmap contains value int. I think that's the very one right there. So what you can see is that when benchmarking runs, it generates these reports for you all on its own. So it pulls the source code directly out of your source file along with the comments, and creates a graph of all the data. And like we said, it started at 10, ended at 200, went in steps of 20. And so laid out a nice graph along that route. And if you're interested in the actual specific data because you want to get a better look at the numbers, you can show a table. Now, this benchmark in and of itself is interesting, and that was useful for us. But we have even more sophisticated kinds of benchmarks. Like, for example, when we moved from GWT 1.33 to 1.4, we did a heavy analysis of array lists. And because we were really, that's such a fundamental data structure, we want to make sure that these things are operating as fast as they can. Well, like I said before, you can actually run these tests in parallel. So what happens is, if you do run them in parallel, the benchmarking system automatically provides this data right next to each other for comparison. So it's kind of easy to get a look at these graphs, and they're plotted along the same domain and range. So you can really just even eyeballing them, you can get a good look for comparison, and you can see how they're just lined up side by side. And if we do a show data on these guys, you can see the tables just pop up underneath them. An even more sophisticated example here is a benchmark method where we test the inserts and we see how that performs. And what's really interesting about this one is, unlike the other test methods that we've seen, this one actually takes two parameters. It takes both the position where we were going to perform the inserts at and the size of the array list. And so if you look at the legend, and again, the benchmarking system automatically created the legends, all of this, based off of just the benchmark source code. So the legend shows that there were 4 different positions that we tested at the beginning, at the end explicitly invaried locations, so random locations, and no location specified is it's really just implicitly at the end. And one of the things that we found with this benchmark is that when we were inserting implicitly at the end, that was good. Like that behavior, that acted like it ought to for an array list. But when we inserted explicitly at the end, it acted really poorly. It acted just as bad as, say, adding at the beginning or adding in random places. And of course, that makes no sense, right?
Yeah, I was wondering, basically, did it work so poorly that once you got past, it looks to me like
Yeah. So let's
1,000
exactly. Let's take a look at the data.
go off?
So if we pull up the charts for these guys, like I said, there are actually two variables. So what happens is as you get more variables, more columns get added because each column is your variable. You can see that the performance for adding at the beginning or things like that is not anywhere near like we only reach 2,000 entries, right? Because basically once you get beyond like the timing there, it took 2.2 seconds to do 2,000 inserts, right, at the beginning, which is pretty miserable, but hey, that's JavaScript. It's actually kind of hard to do much better. And so that's another feature of benchmarking that's actually pretty cool, is what it does is it will automatically look at the amount of time passed and it'll say, you know what, I've reached over about a second and a half, I'm just not even going to do another iteration. So the way this benchmark was written is the parameter, the values were written such that it said, you know what, try inserting and insert all the way up to integer.max range. Integer.max value, I'm sorry. And so it would, if the browser were fast enough, it would try at 4096, it would try at 90 blah, 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 all the way on up. But it only makes it to 2048. Whereas appending at the end, we see is extremely fast. Like if we just implicitly appended at the end, that was great. Well, turns out anyway that explicitly appending at the end was just a bug in our JRE code. So that helped us target a bug, fix that bug, and if you look at later benchmark reports for that, you'll see that this the yellow line and the green line are identical. And you can, like in the same way, if we look at these bottom sets of graphs, like these lines are just all lined up right on top of each other because the performance is exactly the same. Okay, so I'm going to talk a little bit about micro benchmarking, and I don't have I apparently don't have much time at all, so I'll try to speed through it. Micro benchmarks are difficult. I said we support them, but I'm going to take the stance that really, unless you know what you're doing, you probably don't want to write them anyway. Here's an example of a micro benchmark. You would allocate just a single object, and you would say, oh, I want to just see how fast it is to allocate an object. Turns out that's not really a great thing to do. Let's pull the IDE back up again and take a quick look at that and change the resolution for the 5th time. Yeah, so turns out that this isn't a very good thing to do, and the reason why is because it's hard to that operation is so fast that it's hard to kind of it's just about as fast as calling a function. So it's hard to even benchmark out the cost of a function call because the operation is so fast. And if you had a high-performance timer, it'd be easier, but since we have no high-performance timer, we're just kind of screwed. So we can try and do more work in the method. We can basically say, oh, well, you know what, instead of creating one object, we'll create 10,000 objects because, then we'll just get a larger number and we'll just, divide it by 10,000. That'll give us a better result, right? Well, turns out that's not going to work for us either. We have to actually trick the compiler, because if we don't trick the compiler, our compiler is so smart, they'll turn around, it'll just kill the object allocation because it says we don't need it. So we use this really slick thing where we call toString on this object, and the compiler isn't quite smart enough to know that toString has no side effects, and so they'll stick around. But this is pretty dangerous because, probably come around GWT 1.6, we'll say, you know what, toString doesn't have any side effects, and the benchmark will be broken again. So really the best advice for micro benchmarking is if you have to do it, then be very careful and inspect the output of the compiler, because if you don't, you're prone to not be benchmarking the thing you think you're benchmarking. And that's what this is all about. Tips and tricks quickly. I talked about ranges because of the way generators work and how we generate the benchmarks. They have to be subclass accessible, so that usually means like protected. The end lifecycle methods are tricky to write. If you don't write them quite right, you can screw your results. I only graph up to 3 dimensions, so if you have like many variables, I won't create a graph for them because that's a little bit more difficult to do, just a current limitation. If you generate a lot of garbage in a test method ahead of time, it can affect the results of another one. That's a little tricky, especially in IE6, because IE6 has a terrible garbage collector. Benchmarks only in web mode. You really don't want to benchmark in hosted mode. If you benchmark in hosted mode, what you've done is you benchmark Java code. You benchmark the JRE, which really has absolutely no relationship whatsoever to how your production app is going to run. So benchmark in web mode unless you need to debug your benchmark. You think your benchmark is broken. We're considering revamping the UI for benchmarking, doing better comparisons so you can just take arbitrary data sets, lay them out on the same graphs and things like that. Automatic regression analysis, so that way you could kind of like just get emailed, say, if something got slower, which would be really great, kind of cruise control-y, right? And using a high performance timer, say, optionally, like if you're in the hosted browser. And that brings me to the end. If you have more questions, you can go on the Google Web Toolkit Google Groups. You can, if you have suggestions for how you'd like it improved, Google Web Toolkit contributors, or you can even email me. Does anybody have any questions about benchmarking? I think we have like
we can take a couple questions.
a few minutes. I guess you?
If you wouldn't mind just using the mic,
I have other questions I wanted to ask about the unit testing. There's the asynchronous unit testing, which has the delay finish and finish test. I've been writing some tests, and I find I end up with really large classes, and I have to do things like, you've got the flag, which is great to set, but anything more complicated, then your test case gets really hard, and you have to create, like I've had to create my own little mini framework to handle the flags. I'm wondering if there's anyone else has solved this problem, or...
So with the flags, you mean like -web or things like that?
No, more
or?
like the state of your application. So like you got the focus test, like when focus hits, then set the flag. That's a great example. But if you're doing more like the RPC testing where things take a while, or you need the results to compare.
Right, it can get really tricky. Like sometimes you have to chain, right? Like you're in
Chain's a great example, yeah.
Yeah, and I'm not sure off the top of my head how we can improve that, but if you do post something like to contributors, then it's likely to get a lot of traffic, not only from us, but from everybody else. There are a lot of people that visit there, and so maybe we can come up with something better.
Any other questions?
Hi, excuse me. I was interested in the distributed web unit testing. I was wondering if you can maybe talk a little bit more about that. I'd never heard about that before.
Sure, yeah, and you probably haven't heard about it before because we don't talk about it much, even though we use it a lot internally. And so what happens is we have what's called an RMI browser manager server. If you look that up, that's a little RMI application that you start up on whatever machine you want to launch remote browsers from, and you just tell that server what executable to launch. So you can tell it, hey, I want you to launch Firefox or IE or whatever, and you just and then when you launch the client, you tell the client what RMI servers to use. And so, for example, you can tell the client, I want to use RMI server 1, 2, 3, 4, 5, 6, blah blah blah, so on. And it will contact all of those RMI servers in parallel, which will all run the tests in parallel. and collect all those results in a single go.
Is there some place where we can see some documentation or something about that?
To be honest, the best documentation about that is probably in the source code, and you can also do searches on Google Groups. There are other people who've actually used that too. So if you do a Google search, we're pretty good at finding stuff like that.
All right, thanks.
All right, on the other side of the room, one last question.
It looks like the benchmark outputs themselves are generated by GWT or using GWT. So how did you generate the charts themselves?
Yeah, that's a little tricky and a little interesting. There's another undocumented feature of GWT called the hybrid mode, which is only used for unit testing more or less. And what that does is it starts up the hosted browser, it starts up the hosted browser, but it's not for purposes of running Java code normally, which is what happens when you normally use the hosted browser. It's only solely to run a web application, but it also kicks up the Tomcat server behind it and stuff like that. So what really happens is I create an RPC service using hybrid mode, which gets launched with the Tomcat server, which reads all these report files off disks and serves them up via RPC to the GWT app, which I also launch simultaneously, in the hosted browser. So it's actually kind of painful and maybe not the best example of where you would use a GWT app. We're considering as part of the rewrite just to write it as a full-blown application. And part of the reasons why are because you're running in a sandbox, right? So you can't have JavaScript just read files off of disk or other things like that. But I think it's kind of a testament in a way to the flexibility you can really do. Like, it's all packaged up as if it were a normal application. It's all in a single jar. You just launch it, boom, there it is. So GWT's pretty flexible that way.
GWT doesn't actually have charting capabilities. How do you create the chart?
Oh, charting specifically. So that's really interesting too. So I do the charting on the server side. I use JFreeChart, and which is like a LGPL, I think. And so I create that image data on the server based on the request from the client, and then ship. Effectively, just have the client ask for for those image URLs. So the client makes up a URL of a particular path, sets image.source to that URL. The server receives that and generates the image data on the actual literal image on the fly to serve back for that URL.